So we have very well learned how to do Laplace transform. We have very well learned its properties. Now we are going to learn how to do inverse Laplace transform, as that's the third of our tasks, all the tasks that have defined in the first video. All right. So what are the things we're going to do right now? First of all, we need to know partial fraction. This total video is about partial fraction. But before we move on to techniques of partial fraction, we will learn synthetic division, long division. Why is synthetic division necessary? Suppose you are given this fraction, okay, all right, and you are asked to do partial fraction of this. Firstly, your task should be to factorize these third order polynomials, because in partial fraction there can never be any third order polynomial. All there can be is first order polynomial, first order factor and second order factors. So you should know to factorize these third order, fourth order or any order polynomials over 2. All right. So how are you going to factorize it? We're going to do it by synthetic division. So the polynomial we want to factorize is equals to this one, right? So there is a theorem which says that if this polynomial has an integer root, then it's going to be one of the factors of our constant term divided by the coefficient of x to the power m, where m is the orders. That means divided by the coefficient of our maximum term. So the possible roots of this polynomial could be the factors of 24. That means 1, 2, 3, 4, 6, 8, 12, 24, and all with a plus minus before, and coefficient of x to the power m is simply 1. So the possible factors are plus minus 1, plus minus 2, plus minus 3, and so on. We're going to verify which is the root first. Okay, so how about we try for 1? We're going to write down the coefficients ordered by 1, 1, minus 3, minus 10, plus 24. Alright, let's try for 1. So the rule of synthetic division is that the first term comes straight downward, then you multiply these two, that means 1, then you add these two, so that means minus 2, then you again multiply these two, so you get, and then again you add, so minus 12, then you multiply, so that means minus 12, and then again you add, so that gives you plus 12. You see the last term is not 0, so 1 is not a root. I'm not going through the basic algebra, but you can see the pattern. First term gets straight downward, then you multiply with your with the terms that's below the line, and you add these two terms, add the terms with the coefficients, add the multiplication products with the coefficients, and you see if your last term below the line is 0 or not. If it is 0, then it's a root. If it is not 0, it's the remainder when you divide it. Alright, so let's try for minus 1. Alright, 1 minus 3 minus 10 plus 24. So 1 comes out, so minus 1 times 1 is equals to minus 1, minus 3 minus 1 is equals to minus 4 times minus 1 equals to 4, 4 minus 10 is equal to minus 6, and then 6 and 18, so it's also not a root. Alright, so now let's try out 2. 1 minus 3 minus 10 plus 24. Alright, so 1 comes out straight, 2 plus 1, 2 times 1 equals to 2, so minus 1, minus 2 is the product, so minus 2 minus 10 is equals to minus 12, then minus 12 times 2 is equals to minus 24, so the last term is 0 and it is a perfectly root. So 2 is a root, so that means x minus 2, according to our formula, according to our theorem, x minus 2 is a product, x minus 2 is an factor of our polynomial. And if we take x minus 2 out of this polynomial, then the remaining term can be found out from these coefficients. It's going to be minus 12 minus x square. Alright, if we factor out x minus 2, then there is going to be a second order polynomial, 1 degree polynomial less, and the coefficients of those polynomials can be found out from our reminders. Alright, and then we are back with the second order polynomial, which can be factorized by middle term and or minus b square minus 4ac formula, root over b square minus 4ac formula. It can be easily factorized. It's going to be x minus 4 x plus 3. Alright, so first of all, it's synthetic division, and you can see the pattern for third order how what to do. You can see for fourth order what to do. You write down the coefficients, you take the first term straight downward, then you multiply with your guessed root, and simply add it, and then again you multiply and you see whether the last term is 0 or not. If it is 0, then it's the root. If it is a root, then the other terms are simply the coefficient of a remaining polynomial after you take the factor out. All right, so another thing to learn is long division. What is long division? First of all, you need proper fraction. You need proper fraction to do partial fraction. All right, you cannot do partial fraction on improper fractions. Here you see that in denominator the degree of polynomial is higher than the degree of numerator. Sorry, in numerator the degree of polynomial is higher than the degree of denominator. This is called improper integral. Improper integral is whenever you have the degree of the numerator equals to or greater than the degree of numerator. So what to do to make it proper? The idea is to take something common in your numerator and write down your term, write down your numerator terms, and then do plus minus again to balance out. So when I take x common, because I have to, because it is x square minus 2 in the numerator, so that means I have taken an extra minus 2i6, so that is going to be plus 2i6, and when I do division, it's going to be x plus 2i6 over x square minus 2. You see, this is the proper integral which we can do partial fraction, but this is an improper integral which we cannot do partial fractions. All right, and so long division is very easy. You try to make the term in the numerator which is in the denominator, and then you will get some constants or some polynomials and a proper fractions. All right, now what to do, how to do partial fractions. We have learned long division and synthetic division, and so how to do partial fraction right now. So there we have learned that any polynomial can be written as product of first order factors and second order factors. Second order factors are those which cannot be reduced to product of first order factors, and they are called irreducible factors. So first of all, we might have degree 1 factors and non-repeated factor. That means none of them has the power more than 1. So there is a really straightforward shortcut to solve, to make partial fraction of this sort of terms. I'm not going to explain why the working rule works, but I'm just going to let you know about the rule. All right, so there are two factors in the denominator. First factor is x plus 2, so that means the root is minus 2. So at the remaining portion in your function where there is x, you replace minus 2. So it's going to be minus 4 when you replace, and it's going to be minus 2. And here the remaining factor is x minus 2, so that means the root is 2, and at the remaining portion in your fraction where there is x, you simply replace 2. So 2 plus 2 equals to 4, and it's 2, so it's going to be half 1 by x plus 2 plus half 1 by x minus 2. So it's very simple when degree 1 and non-repeated factor. Secondly, it can be degree 1 but repeated factor. So right now your shortcut doesn't work, and you have to follow some straightforward rules. You have to guess how your partial fractions is going to be. So the working rule is that I'm going to write down it first of all. Okay, the working rule is that if you, for each factors you make out terms, and so the working rule is that for each factor you make out separate terms, and the numerator you guess is going to be 1 degree less than the denominator. So here the factors are of first degree, so the numerator is going to be 0 degree or simply a constant. so it's going to be a. And for repeated terms of, that means when there is a power of x plus 2 square, for repeated terms you gradually increase the power of your denominator. It's called Aufbau rule. You slowly build up your power till you reach the power in your fraction. So here is going to be b and here is going to be c, because the denominator is simply first order, and that's our perfectly a good prediction of our partial fractions. Alright, so secondly what you do is that you multiply both sides by the denominator of your fraction. So it's going to be a x equals to a x plus 2 square plus b x minus 2 x plus 2 plus c x minus 2. Secondly, what you can do is to you put some critical values of x that will give you the value of some constants. Not all, you are not going to get all constants, but some constants. Suppose you put x equals to 2 here, then we get 2 is equals to, as x equals to 2, the b term and c term is going to become 0, so you are simply going to get a times 4 square, so a times 16. So a is simply going to be 1 over 8. Nextly, what you can also put is x equals to minus 2. Alright, so if you put x equals to minus 2, this term and this term will become 0, so minus 2 will become b minus 4. Sorry, this term and this term is going to be 0, so minus 2 will become c minus 4, so c will become simply half. Now to find out the value of b, you need to equate the coefficient of some x term or x squared term. The easiest in this way, in this example, is to equate the coefficient of x squared term. There is the x squared term here with the coefficient of a, and there is the x squared term here with the coefficient of b, a plus b, and there is a no x squared term in the left hand side, so a plus b has to be 0, so b has to be minus 1 by 8. So that's how we find out all our numerator value. So type 3 and type 4 can be that you have non-reducible second order fraction, and you have non-reducible second order factor, and also the factor is repeated. So what can you do right now? Your task simply will be to predict first of all how the partial fraction is going to look. So there is a separate term for my non-reducible factor, and there is a separate term for my simple first order factor. And as it is second order factor, so the numerator is going to be 1 degree less, so that means first order, so it's going to be bx plus c, and it's going to be 0th order or simply constant a. Now you multiply by the denominator of your fraction, so that becomes bx plus c